Hello class. In these sessions, before we going into STL in detail, I will first introduce you vector, which is in standard template library. So let's begin. We already know C array. We often use array when we do programming, but it has significant limitations. Its size is fixed. So once your program creates an array, the length of the array cannot be changed while the program is running. It is very inconvenient because there are situations in which the length of the array is not known at the time of writing your program. The correct size of the array may be only known in runtime. So we need some kind of dynamic array where the size of the array is not fixed. And here the vector comes. The vector can be sort of as array, but its size can change while the program is running. So vector is good because we don't need to worry about the size. The size of the vectors will automatically grow or shrink as demands. If we need more capacity to store new elements, its size will be automatically increased. So unlike array, programmer doesn't have to think about the size, and programmer also do not need to care about the memory allocations and the allocation when size is growing or shrinking. So it's very convenient compared to C arrays. And since we learned classes and templates in previous week, I think it is good time to talk about vectors because vector is a template class. We learn all the concepts that needs to understand the vectors. And because vector is a template class, when you declare the vector class, you have to specify the base type within angle brackets shown here. You can simply think of this as specifying a base type for an array. If you do this, then the compiler will automatically generate classes for vectors that works with given base type. For example, here we specified int. So the compiler will create vector class that works with int type of values. And because vector is placed in std namespace, you have to specify std like this, or you can just write using namespace std at the top of the file and remove this std and scope resolution operator. Because vector is a class, not a template class, the default constructor of vector class will be invoked in this line. And the object of the vector class type, which can work with int type, will be stored into this v variable. And we can access the elements stored in the vectors using square brackets notation, just like an array. Shown here, square bracket notation. We use square bracket notations when we try to access the element stored in array. We can do that for vector as well. But there is restrictions on using the square brackets notation in vectors. You cannot use square brackets notations for initializing elements. You can only use square brackets to access elements that have been that have already been initialized before. So to add a new element, you have to use push back member functions. You cannot add new element by using these square brackets. And by calling the size member function defined in vector class, you can obtain the current size of the vectors. Because vector is a template class, so it has several member functions. There are other convenience member functions defined in vector class. Visit this link, you can find other member functions in vectors. Let's look at an example code of using vector. Let me show this example in terminal. So this is the example code. Let me first compile this program and show you the output of this program. Let's enter. Okay, so this is the output. Okay, let's look at the demo code here. First of all, because vectors are defined in library vector, you have to include vector library like this. And if you look at the main functions, it first declare the vector class here, where the base type is int. So this vector class will work with int type of values. And at this point, the default constructor will be invoked. And the objects of this class type will be generated and stored into this variable. And here, it's console output. It's asking user to enter list of positive numbers and place a negative number at the end. And the program receives users' first input in this line and adds the input, user input, which should be a positive number in vector using pushback member functions. You have to use pushback when you are adding a new elements. You cannot use this one. Let me, for example, you cannot do this. So if I do this, this may compile well, but so this compiles well, but do this, unexpected result occurs here, segmented fault occurs here because of this line. So you cannot do this. You can only access the initialized elements using these square brackets. And because currently this one is new elements, you cannot use square bracket to add new elements to the vector. So you have to use these pushback member functions. And so this while loops stores all the user's input. So in this example, if this is the user's input, inside of this while loop, 2, 4, 6, 8 is stored into this v vector using pushback member functions. So shown here. So after adding the elements, we print the element value and add it. And here, this one, 2 added, 4 added, 6 added, and 8 added. And as you can see here, the size member functions returns the size of the vectors. and the size of the vector is dynamically changes. Unlike the array where the size of the array is fixed, the size of the vector is keep changing whenever we added new elements to the vectors. So that is the big difference between vectors and array. And here we just print all the elements stored in the vector using a square bracket notation. Now we can use a square bracket notation because the elements are initialized through these pushback functions. So now this is fine. So shown here, usually we use a for loop to iterate all the elements stored in the vectors, and for that case we use size member functions. This returns the number of elements stored in the vectors. So if you look at this code, we are not caring about the size of the vectors. So we do not specify the size of the vectors, or we do not increase the size of the vectors here. We just add new elements here. We just add new elements inside of this while loop until we meet the negative number, so we meet the -1 here. So using this code, we can add 10 elements or 20 elements, 30 elements, or even 100 and 1,000 elements into this vector. So that's the advantage of using vectors. It works with any number of elements. So, and you don't need to worry about the size. Okay, let's go back to the slides. So this is the demo code we saw in terminal. The vector is convenience because we don't have to worry about its size as we saw through the demo code. Now let's talk about the efficiency of the vector. The vector class has a member function named capacity. Do not confuse the capacity of a vector and the size of the vector. In the previous slide, we saw that we can get the size of the array, size of the vector using size member functions. The size of the vectors and the capacity of vectors are not the same thing. The size indicates the number of elements stored in the vector, and the capacity indicates that the current total number of elements that the vector can store. So they are different. And this number, the capacity can be increased and decreased. So they are different, and because capacity indicates the current total number of elements that the vector can store, the capacity is always greater than or equal to the size of the vector. So whenever a vector runs out of capacity and need more memory to add new elements, the capacity is automatically increased. How much the capacity of the vector increase automatically depends on the implementations, but commonly the capacity increases by double. Increasing capacity is a complex task and involves memory reallocations, which may affect the efficiency of your program. For example, if your program uses a large number of elements, reallocating large chunk of memory in one time could be more efficient than allocating small chunks of memory in multiple times. For that, instead of relying on default implementations, you can explicitly increase the capacity of a vector using reserve functions. Reserve is also a member function defined in the vector class. Here we are changing the capacity to at least 32 elements. And for this line, we set the capacity to at least 10 more than the number of elements currently in the vector. So like this, you can control the capacity of the vector. You don't have to rely on the default implementations. But so if efficiency is an issue, use these reserve member functions to control the capacity of your vector. But if not, you can just completely ignore the capacity of the vector. The capacity of the vector will be automatically increased as needed. This example code shows how capacity of the vector changes. So let's look at this code in the terminal. Okay, so we are using a vector here. And because vector is defined in vector library, we include here. We include vector library here. Let me first show you the output of this program. Okay, this is the output of this program. Let's look at this. We first declare the vector class here. Base type is int, so this vector variable will work with int type of values. It first prints the current capacity of this vector. And if you look at this output, the current capacity is 0. Here we have elements of 6 elements in non-array. And using this for loop, we are storing each element stored in non-array into this vector using pushback member functions. And every time we added new elements to these vectors, we print this line, which is after insert I is a value of elements capacity. So each time we added new elements, we print the value of new elements and the capacity of the vector. And this line corresponds to this 2, 3, 4, 5, 6 line, because we are adding 6 elements stored in non-array. So first of all, we added 0 because the array 0 indexes value in this array is 0. So we are adding 0, 1, 2, 3, 4, 5 to this vector. So that is the reason why you printed 0, 1, 2, 3, 4, 5 here. And note that capacity also changes here because we capacity prints here. Originally the capacity was 0, but after adding 0 elements to the vector, the capacity changes to 1. And after adding another element, which is a 1, the capacity changes to 2. And after adding a new element 2, the capacity changes to 4. And if we add a new element here, it still 4 because you can hold this number within this 4 capacity. And when we try to insert this new element, the 4 value, the capacity increases because capacity should always be greater than or equal to the number of elements stored in the vector. So the capacity increases here, and new elements here, adding new elements here, the capacity is still 8. As you can see here, the capacity grows double, 2 to 4, 4 to 8. So By default, the capacity increases by double. This example shows that. And here we just print the elements stored in the vector using a square bracket notations, just like an array. So, and we use a size member functions for that. So it just prints the elements stored in the vector. And here we print the current capacity of the vector, which should be A. So it prints 8. And here we explicitly controls the vector's capacity using our resolve member function. So we are changing the capacity of this V vector to 100. And we print the capacity again. As expected, the capacity changed to 100. So this example shows a lot of things here. You can explicitly control the capacity by using these reserve member functions shown here. And you can access the elements stored in the vector using these square bracket notations here. And you can add new elements through the pushback member functions. And the capacity automatically grows by double, shown here. And initially the capacity is 0 by default. So hopefully you understood vector. We will talk about the standard template library, more about standard template library in the following session. So see you in the following sessions.